Hi guys, welcome to the lesson on direct and inverse variation, and you should be doing this on 4/17/15. Alright, so we're going to define direct inverse variation, identify situations involving direct variation, solve algebraic problems related to direct variation and inverse variation, relate direct variation to the graph of straight line, graph inverse variation, and identify the graph as an equilateral hyperbola. So for the do now, I really would like you guys to be able to just work on it, and definitely we'll I want you to complete for this question. All right, and then let's move on into the lesson. So vocabulary plays a big role in this lesson, direct and inverse variation. And when you see direct variation, know that it must be speaking about multiplication. So direct variation, when you hear direct variation, then you know it's multiplication. So if the value of x is increased, then y is increased as well. So they're moving along the same kind of, they're moving concurrently as well. Both variables change in the same manner. If x decreases, so does the value of y. We say that y varies directly as a value of x, and this is what you look for in a lesson, in a question. So direct variation is definitely multiplication right there, where the value k is called the constant of proportionality. Unfortunately, most questions, they don't give you k, so you have to find k based on some known value of the other two variables. In most problems, the k value needs to be found using the first set of data. Very important, very important. Alright, so let's look at a model example. The power P of a gear varies directly. So there is our key term, varies directly, with the radius r of a gear. Find the constant of proportionality if P is 300 and R is 50. So here we are looking at the first set of data given to find K. That's the only thing we have to do in this question. And we know that because it varies directly, then uppercase P is equal to K times R. So then P is 300, we substitute in, and K is not known, and R is 50. It's a radius. So 300 is equal to K, 50 or 50K, no problem. To find K, we simply divide by 50, and then K is equal to 6, right? So that's a method to find K. You could also do literal equations, and so K will be equal to P over R, which is the same thing that we do. Next example, and now this is a typical direct variation. In a factory, the profit P varies directly, again, our key term. So we know we're multiplying with inventory, I. If P is 100 when I is 20, so those are the first set of data. Obviously, we have to find K because K is not given. Then they want us to use that to find P when I is equal to 50. So we have to find the K using first set of data. And our first set of data is P is 100 and I is 20. So P is equal to K times I. And P is 100, K we don't know, I is 20. We're going to divide by 20 to find out what K is. In this case, K happens to be equal to 5. Not bad. Now they want us to find P when I is 50. So now we know what K is, so it's simply put substitution. So let's go. So P again, let's write our equation. Now P is substituting, K is 5 and I is 10 for this case, so P has to be 50. Not bad, right? Awesome. Now let's look at joint variation. Sometimes more than one variable is involved in a direct variation problem. In these cases, the problem is referred to as a joint variation. The formula remains the same. with the additional variables including the product. For example, if P varies jointly as the values of R and S, then the formula will be P is equal to K, that's a constant of proportionality, times R and S. So all you're doing jointly is that you have an additional two other values that varies along with P. All right? So let's look at this example. Variable M varies jointly, and I want you to really pay attention to vocabulary. Underline certain things you see so it helps you to know what you need to do. As the values of P and M. If M is 88 when P is 4 and Q is 4, find M when P is 8 and Q is 1.2. Obviously, we have to find K first since they had those first set of data given. So we have our equation here. Now, in this case, M is 88, K is not known, then we know that P is 4 and Q is 4, so 88 is equal to 16 times K. I choose to put 16 as a coefficient, then we're going to divide by 16 to find out what K is, and K happens to be, K is equal to 5.5. Now we need to find out, we need to answer the question. They want us to find M when P is 8 and Q is 1.2. So M, we don't know in this case. We're going to put the equation so we don't forget it. M is unknown. K is 5.5. P is 8. And Q is 1.2. So M happens to be 446.6. If there are any mistakes I'm making, please make sure you make the corrections and let me know, okay? All right, so definition on the regions, inverse variation. This is definitely on the regions. Opposite of direct variations. Opposite of direct variation, we know derivation was multiplication, so inverse variation must be division. And then inverse variation, the values of two variables change in opposite manner. As one value increases, the other decreases. Inverse variation, when one variable increases, other decreases. So as speed decreases, the time increases. So that's an example of inverse variation. Notice the shape of the graph of inverse variation. If the value of x is increased, then y is decreased. If x increases, the value of y, if x decreases, the value of y increases. We say that y varies inversely as a value of x. An inverse variation between two variables y and x is a relationship that is expressed as, voila, y is equal to k over x. So now when we see inverse, we're looking for division, obviously, where the value of k is called the constant of proportionality, as we know already. So let's look at an easy example. So the number of hours h it takes for a block of ice to melt varies inversely. There is our key term. We know that we have to divide as the temperature T. If it takes 2 hours for a square of inch of ice to melt at 65 degrees, find the constant of proportionality. Now, in this case, they want us to find the constant of proportionality. We know that is K, and they have some given data. So let's go. H, and it varies inversely, so K goes on top, T goes on the bottom. So now it says that hours is 2, K we don't know, and it melts at 65. So we can create a proportion here. Not bad. So we could do our cross multiplication. 2 times 65 is 130, and K times 1 is equal to K. So K is equal to 130, and that's our final answer. In a formula, Z varies inversely as P. If Z is 200 and P is 4, find Z when P is equal to 10. Of course, we see the keyword, it says varies inversely. So Z is equal to K over P. Do we have K? No, so obviously we have to find K. So let's go. So we know Z for the first set of data, we're using the first set of data, is 200 is equal to K over 4. We're going to do our cross multiplication. 200 times 4 is 800. And K is equal to 800. Now they want us to find Z when P is 10. So Z we don't know. P, K now is 800, and we know that P is 10. So Z in this case becomes 80. My question is answered. It took a few steps, but I was able to get there. All right. In kickboxing, it is found that the force F, and force is like pressure, needed to break a board varies inversely with the length L of the board. It takes 5 pounds of pressure to break a board of 2 feet long. So of course, when they give you this, they're going to find K. How many pounds of pressure will it take to break the board that is 6 feet long? So let's find K first. So F varies inversely with length. So it's K over L. So in the first set of data, we know force is, pressure is 5, K we don't know. And then we're going to cross multiply. So K is equal to 10. All right, so let's answer the question now. F is equal to K over L. F is equal to 10. We know that K is 10, and we know that L is 6 for this section, so it's equal to 1.6, or for a more exact answer, it's 1.1 2/3 pounds. All right, if you hear some background noise, it's because I'm working in the lobby of the hotel. But anyway, let's go. So M varies directly. Now we see a difference. It's directly, right, as variable T, and inversely as a variable S. If M is equal to 24 when T is equal to 3 and S is equal to 2, find M when T is equal to 5 and S is equal to 8. So you could pause the video and you could go ahead to try the U-tries, okay? So we know that it actually has a 2. T varies inversely, and T varies directly, and S varies inversely. So we have a situation like this. If T varies directly, we know T is multiplying. And if S varies inversely, you don't have to write another K, it just needs one K. So that means S becomes our denominator. So now we're going to use the known data and we're going to find the K. So M is 24, K we don't know. T is 3 and 2S is 2. So we're going to just 24 is equal to 3K over 2. We can cross multiply. And we end up with, so we cross multiply. That is, I'm just going to do it over here, I'm sorry. So 2 times 24 is 48, and then we have 3K dividing by 3. K becomes, how many times? There's 16, right? Alright, so now let's move on. So now they want us to complete the question, right? So to complete question, we're gonna find what M is when we have some other data. So M we don't know, K is 60, T is 5, in this case S is 8, as given here. So M happens to be 10 after you do all of that. Alright, this video is not very long, but what I'd love for you to do now is I want you to go to JMap and you could pull up some questions on the smartboard. And I'd really love if you guys did the questions and you could print out those same questions and try it at home. Alright, but it'd be nice if you guys work together as a team, as you always do, and get these questions done. Alright, so as always, we always want to talk about the strategies that we use to complete the questions. So the first thing we notice is that we have to pay attention to vocabulary. And we'll talk about vocabulary to determine formula. Alright, so and then the K is the constant of proportionality. And we have to use data. Use known data to find. Alright, so for homework, please complete this note sheet and present for grading on the due date that will be assigned. And I'd love you to have this by Monday. And Monday will be the 20th of April. Oh, all right. So let's. I just want to look at some vocabulary. So let's review. Let's review. If you hear F varies as X, then it means that F is equal to K times X. F varies jointly as X and Y. It means that F is equal to K times X times Y. If F varies as X plus Y, it means that F is equal to K parentheses X plus Y. If F varies inversely as X, it means that F is equal to K over X. So have this note sheet done and bring it in on Monday, and I'll see you then. Bye.